Hello, everyone. In this lesson, we will continue to study the concept of the armature reaction. Armature reaction refers to the effect of the armature magnetomotive force, Fa, on the excitation magnetomotive force, Ff, when a synchronous generator operates under symmetrical load. The nature of the armature reaction includes direct access, demagnetizing armature reaction, direct access, magnetizing armature reaction, and quadrature access armature reaction. The nature of the armature reaction depends on the internal power factor angle, which is the angle between the no-load electromotive force, E0, and the stator current, I. The magnitude of the internal power factor angle is related to the load size and the nature of the synchronous generator, as well as the parameters of the machine. 1. Armature reaction when the internal power factor angle is minus 90 degrees. The armature magnetomotive force, Fa, and the excitation magnetomotive force, Ff, are in the same direction. The magnitude of the combined magnetomotive force increases. At this time, the armature reaction is called direct access magnetizing armature reaction. It can also be seen from the figure that, at this time, the armature magnetic field interacts with the rotor excitation windings to produce electromagnetic force. No electromagnetic torque is produced on the rotor due to the increase in the combined magnetomotive force. The terminal voltage of the generator rises. To maintain the generator's terminal voltage, the excitation current of the generator must be reduced. At this time, the generator outputs reactive power. 2. Generally, when the internal power factor angle is 0 to 90 degrees, the stator current I is decomposed into direct access component ID and quadrature access component IQ. The direct access component ID produces direct access armature magnetomotive force, FAD, which has a demagnetizing effect. The quadrature access component IQ produces quadrature access armature magnetomotive force, FAQ, which has a magnetizing effect. At this time, the nature of the armature reaction is both quadrature access armature reaction and direct access demagnetizing armature reaction. At this time, the generator outputs both active power and reactive power. To summarize, the armature reaction when the internal power factor angle is 0 degrees is quadrature access armature reaction, abbreviated as quadrature access. It causes the generator's speed and frequency to decrease To maintain constant speed, the input mechanical power of the prime mover must be correspondingly increased. Therefore, the quadrature axis armature action achieves the conversion of mechanical energy to electrical energy. The generator outputs active power. The armature reaction when the internal power effect angle is 90 degrees is the armature magnetomotive force, Fa, and the excitation magnetomotive force, Ff, combine in opposite directions, reducing the magnitude of the combined magnetomotive force. At this time, the nature of the armature reaction is direct axis demagnetizing armature reaction. Due to the reduction in the combined magnetomotive force, the terminal voltage of the generator decreases. To maintain the generator's terminal voltage, the excitation currents of the generator must be increased. At this time, the generator outputs reactive power. The armature reaction when the internal power factor angle is minus 90 degrees is the direct axis magnetizing armature reaction due to the increase in the combined magnetomotive force. The terminal voltage of the generator rises. To maintain the generator's terminal voltage, the excitation currents of the generator must be reduced. At this time, the generator outputs reactive power. Armature reaction is the key to achieving the conversion of mechanical energy to electrical energy. Figure A shows the quadrature axis effect of armature reaction. The electromagnetic force is opposite to the direction of rotation. To maintain the generator's constant speed, it is necessary to adjust the input power of the prime mover in accordance with the changes in active load. Figures B and C show the direct axis effect of armature reaction. Figure B shows the demagnetizing effect, and Figure C shows the magnetizing effect. To maintain the generator's terminal voltage, it is necessary to adjust the rotor excitation current in accordance with the changes in reactive load. Generally, the generator carries both active load and inductive reactive load. Changes in active current affect the generator's speed and frequency. Changes in reactive currents affect the generator's voltage. To maintain the stability of the generator's frequency and voltage, it is necessary to adjust the input power and excitation currents of the generator in time with load changes. In summary, the existence of quadrature axis armature reaction is the key to achieving the conversion of mechanical energy to electrical energy. In this lesson, we learned the basic concepts of amateur reaction. I hope everyone consolidates the knowledge learned from this lesson with practical exercise. That's all for this lesson. Thank you, everyone.